distance versus time graph when speed increases uniformly, or displacement versus time graph when velocity increases uniformly, right? So let us consider one example. Here the speed should increase uniformly. So let us consider in every second the speed is increasing like this, or velocity is increasing like this, 0 to 4. Here we consider time in seconds. Here seconds, here 1 2 3 4 5. The velocity is increasing like this, 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. Means the increase in velocity in every second here is 4 meters per second, 4 meters per second, 4 meters per second, 4. This is actually constant. Increase in velocity is constant here, not acceleration. Here the increase in velocity every second is constant here, nothing but increase in velocity or decrease in velocity in every second is called acceleration. There is nothing but here acceleration is constant. In physical science, constant acceleration we term it as uniformly accelerated motion. Uniform acceleration, or the motion is called uniformly accelerated motion. Alright? But we have to draw the graph between distance or displacement versus time. So in every case we have to calculate displacement covered by the object. As we are considering at the initially the velocity is 0, thus the displacement will be 0. For calculating displacement, I am using the formula u plus v by 2 into t instead of ut plus half at square, because I have here final velocity also, and also I have time. Then using this formula, if you use this formula, calculation will be simpler, right? That is why I am using this formula. So at the end of 1 second, initial velocity always 0, final velocity is here is 4. At the end of 1 second, final velocity is 4. 0 plus 4 by 2 is 4 by 2 into 1. 4 by 2 is 2. 2 into 1 is 2, 2 meters. At the end of 2 seconds, velocity is 8 meters per second. So 0 plus 8 by 2. 0 plus 8 by 2 into 2. 8 by 2 is 4. 4 to 8. So at the end of 3 seconds, the velocity is 12 meters per second. So 0 plus 12 by 2, 6, 6 into 3, 18. At the end of 4 seconds, initial velocity is 0. At the end of 4 seconds, velocity is 16. 0 plus 16 by 2 is 8, 8 4 is 32. Similarly, at the end of 5 seconds, 0 plus 20 by 2 is 10, 10 5 is 50 meters. If you observe here, by the end of 1 second, the displacement covered is 2 meters. But the end of 5 seconds, nothing but in 1 second, the displacement covered is 2 meters. In the last 1 second, the displacement covered is 18 meters, because here the speed or velocity is more here. Now, if you observe here, the displacements are 2, 8, 18, 32, 50. So we better go with 10 units on y-axis as displacement or distance. On x-axis, we take time in seconds, 1 2 3 4 5. At the end of right at the end of 1 second, 1 2. So here 1 on x-axis, on y-axis 2. It is 10. 2 will be somewhere here. So 1 comma 2. 2 comma 8. 2 comma, it is 10, somewhere here 8. So 2 comma 8. At the end of 3 seconds, 18 meters. 3, here is 20, somewhere here 18. 4 comma 32. 4 is here, 30 is here, so somewhere upside 32. So 4 comma 32. And 5 comma 50. So if you join them, you will get a graph like this, which is called actually a parabola. It is a parabolic graph, and this is distance versus time graph when velocity increases uniformly. When velocity or speed increases uniformly, this is distance versus or displacement versus time graph. Thanks for watching.